Good evening. So let's begin. So in the last lecture, we have looked at definite integration, right? And we have discussed a little bit about how to substitute limits and calculate definite integration. So we will complete that portion of calculus today, and we'll be ready to start with kinematics after that. So let's begin. So you also discussing integration by substitution in the last lecture, and we had seen some examples of that. So that is again something that we'll be reviewing today, but we'll start with the review of definite integration and see a few more cases of that. Okay, we've completed the theory part of definite integration also, but we need to practice certain types of integrations with limits, etc. So what we saw last time is the symbol for definite integration is a regular integration symbol, but with two numbers above and below written like this, along with the integration symbol. So this is then read as the definite integration of the function fx with respect to the variable x from lower limit. Okay, so these are called the limits. Lower limit x equal to a to upper limit x equal to b. And then this one's calculation is done by first calculating the antiderivative, and then on the antiderivative we put the same limits x equal to a to x equal to b. And final step, we substitute the upper limit in the antiderivative, the lower limit in the antiderivative, and subtract the two. So the value that we get from this is the definite integration with the limits a to b. So let's quickly once again understand this process of substituting limits with a couple of examples. So for example, I want to calculate integration of x square from 0 to 2. So first I'll calculate the indefinite integration, which is x cubed by 3 plus c. And on that indefinite integration or that antiderivative, I'll put the limits x equal to 0 to x equal to 2. So the upper limit will become 2 cubed by 3. The lower limit will become 0. C will cancel out, and ultimately I'll be left with 8 by 3. So this is the value that we get for that definite integration of x square from x equal to 0 to x equal to 2. Yes, Manav, we will be in the process of doing many more examples. Okay, let's look at another example of definite integration now. Let's look at this example. Sometimes in the limits also we can put x equal to lower limit to upper limit, or we can just write 1 to 4 also. They mean one and the same thing. If I just write 1 and 4, that also means the same thing as x equal to 1 to x equal to 4. So anyhow, so just write down the first example and try this one yourself. Just apply the same method over here and apply and find out the value of this definite integration. So hope the steps in the first one are clear to all of you. We have done the integration of x squared from 0 to 2. How the limits have been substituted, and most importantly, after substituting the limits, when you subtract, the constant of integration c cancels out. So that's how we get just the value 8 by 3.
Sir, I have sent you my answer.
Yes, people, I'm just verifying the answers. Okay, unfortunately, none of the answers yet are correct, but I'll just explain once more.
थोड़ा थम गए।
Okay, so let's go through this. Okay. So first of all, what is the indefinite integration of root x? It is x to the power 3 by 2 divided by 3 by 2 plus c, or 2 by 3 x to the power 3 by 2 plus c. So therefore, if I put the limits on this one, 1 to 4, then I have to put the same limits on this antiderivative. So the upper limit will become 2 by 3 into 4 to the power 3 by 2 plus c, minus the lower limit is 2 by 3 to 1 to the power 3 by 2 plus c. So the upper limit becomes 2 into 8 by 3, that is 16 by 3 minus 2 by 3. So 14 by 3. Couple of people have sent the answer as 14 by 3, that is correct. So Akshat and Sanvi, both of you have got the answer correct. Okay. In case you're wondering how that 4 to the power 3 by 2 was calculated, 4 is 2 square. So this becomes 2 cubed, which is 8.
Sir,
Anyhow, yeah. Tell better, which example? I mean, which part is not clear?
no, sir, it's clear. I just said you to wait.
Just write it down, it's fine. Okay, I'm not removing it. Now that is the formula, better. That is the formula of this integration. Integration of x to the power n is x to the power n plus 1 upon n plus 1. Okay. So when I put n's value as half, then we are getting this integration. Okay, let's look at a couple of more examples. So the last one, the limits are from -1 to 1. Just try this out, people. Okay, people, I'm waiting for more answers. I'll tell you who all have sent the correct answers so far. Just a second. Yeah, Ayan, your first answer is correct. Your second answer bit is not correct. Okay, third one is again correct. Oh, no, third one is also not correct. So only the first one is correct. B and C, check your calculation once more, Ayan. Okay. Anahita, your answers are correct. A and B. Sanvi, your all three answers are correct. A, B, and C. Swayam, your first answer is correct. The second one is you made some calculation mistake. So I'm just putting the values of the answers for the first three. I'll give you the methods in some time. Okay, so I'll verify all the answers now. Now I have received one doubt from somebody, that is 0 the same thing as 0 radians. Yes, that is true, because the relationship between radians and degrees is that pi radians is equal to 180 degrees. Therefore, x radians is equal to x upon pi into 180 in degrees, or y degrees is equal to y upon 180 into pi radians. So you can see that relation. So that's how we get, for example, that 30 degrees is equal to pi by 6 radians. Okay. 120 degrees is 2 pi by 3 radians. 0 degrees is equal to 0 radians. So that's the thing. Okay.
So
Now
this
let's work out.
you are illustrating.
Now somebody had a doubt whether 0 degrees is the same as 0 radians. Somebody sent me a text message for the doubt. So that is just clearing that doubt. So this is aside from this question. This is the relation between degrees and radians. The interchanging or relationship between degrees and radians. That's that one. Now let's come to the question. The first one is integration of cos x from 0 to pi by 2. Now remember that the integration of cos x is sin x from 0 to pi by 2. So the upper limit is sin pi by 2. From now on, I'm not going to write the c because anyway it cancels out. So sin pi by 2 is 1, sin 0 is 0. So the answer is 1. That's how we got this answer as 1. Similarly, the second one, now many of you got the second one wrong because I'm thinking that you integrated it wrongly. You have to remember that sin x's integration is not cos x, it is minus cos x. So when you put the limits, it becomes minus cos pi by 2 minus of minus cos 0. Now cos pi by 2 is 0, but cos 0 is 1. Okay, Sakshi, very good. I'll verify the answer. It seems correct.
So
So now,
in integration, the conversion of cos x to minus the conversion of cos x to sin x is same as the derivation, or it is different?
that's a formula. Integration of sine is minus cos.
Sir, the second one in B wala minus cos of 0, that whole will become 0, right?
No, beta. Cos 0 is 1.
We will be only left with 0. Yes, that is
No, cos 0 is not 0, beta. Cos 0 is 1. Cos pi by 2 is 0. You understood, beta? Cos 0 is not 0.
Yes, sir. Yes. Thank you.
Cos 0 is equal to 1. And cos pi by 2 is equal to 0. Okay. Now moving on. The third one is the same integration, but the limits are different. 0 to pi cos x is sin x plus c 0 to pi. So that will become sin pi minus sin 0. Now sin pi is 0. So the answer is 0. You have to remember the way of calculating sine in second quadrant. when theta is between 90 and 180, we say sine of theta is the same thing as sine of 180 minus theta. So therefore, for example, sine 120 is the same thing as sine 60 is root 3 by 2. Sine 150 is the same thing as sine 30, which is half. But like that, sine 180 will be the same thing as sine 0, which will be 0.
Sir,
That's how we get sine pi is 0. Yes.
sir, sine 180 we can write as cos 90.
Yes, that's also correct. We can also write it as cos 90.
Sir, so cos 90 will be 0 and then answer my came. It will be okay, no?
Yes, yes.
Okay, sir.
So this thing can also be equated with cos of theta minus 90. Okay. So you can see that that's why sine 60 is the same thing as cos 30. Or sine 150 is the same thing as cos of 60. And that's the same thing as cos of 90. But generally, I prefer this formula because it's easier to remember that sine remains sine when we subtract from 180. But you can use this formula also. There's no harm in that.
Sir,
Yeah.
what you have written in the red one?
This is the formula for sine in the second quadrant. Remember, I have taught you this when we were discussing differentiation earlier.
Okay, sir.
This is a formula, and these are examples I'm showing you that example sine of 120, sine of 150. So similarly, what is sine of 180? It comes out to be 0. Sine of 180 is the same thing as sine pi. The question here was, how did sine pi come out to be 0? So the answer to that is this. All right, let's come to the third question. Sorry, the fourth one. What was that now? Yeah, 1 minus x from 0 to 2. Okay, so let's calculate this integration. Integration of 1 minus x dx from 0 to 2. So first we integrate this quantity 1 minus x. So it should be how much? X minus x square by 2 plus c. And on that we'll put the limits 0 to 2.
Sir, here we don't have x raised to the power of n. So how?
We have x to the power 1 है ना, तभी वहीं से तो x square by 2 आया. Integration of x dx is integration. That's how we get this formula. Na?
Oh, okay.
And integration of just 1 is x. So we are using these two integrals here. Now put the values, so you'll get 2 minus 2 square by 2 minus 0 minus 0. Interestingly, you again get 0. So this one's answer is also 0. It's actually not a coincidence that is 0. There is a logical reason why that's happening, and that also we'll discuss when we see the geometrical meaning of definite integration. We'll discuss that next. But first of all, I want you to all to go through this very carefully, these 4 examples. And the fifth example I'm just writing over here, we'll discuss 4x cubed dx. We wanted to integrate from minus 1 to 1, from x equal to minus 1 to x equal to plus 1. So just
Sir,
try with, yeah,
so can you just check my fifth answer I have sent you?
yeah, I'll just check.
So can you please scroll it down?
Yeah, I'll scroll down. Fifth answer, so far only one person has got correct, and that is Sakshi.
So,
Oh, sorry,
So
no,
in the-
Sakshi. Wait, just a minute. Fifth one, sorry, Sakshi, your answer is not correct. In fact, the only person who has got it correct is. Oh, Piyu, yours is correct. Very good. Swam, yours is also correct. Manav, yours is correct. And Ayan, yours is correct.
Sir, me too.
Yes, yours is also correct. Very good.
So,
Yes.
so in the D part, the integration won't it be like x plus x square upon 2?
Plus nahi hai beta, because there's a minus sign between these two. No? It's 1 minus x. So it will be x minus x square by 2. You understanding? No? See here the sign is minus no, between these two. So here also the sign will become minus. Okay, I have just put up the answer of the fifth one. Also try to work it out. Those who haven't got it yet.
Mine was right.
I did not get the differentiation of integration of D part. Can you show it like in detail?
Of which one, beta? Which part?
D, the D1.
D part. D ka to I've done the integration here. Na? See, there are two parts. Na? It is, see, x dx is integration is how much x square by 2. And 1 is basically 1 into dx. Its integration is how much x plus c. So that's it. Na? You have to break this up like this. No? It is dx minus x dx. Okay, so dx's integration is what? It's x. X's integration is x square by 2. Okay, now on this you put the limits. So finally on this also we are putting the limits. So that's how we got this. Understood now? No?
Yes, sir, understood.
Now this one, just check if you are all getting the answer correctly. Okay, 4 of you send the answer correctly to me. Mention those.
So, so in this second quadrant, it is cos theta minus 90 degree, right?
Yeah, cos theta minus 90. Second quadrant, sine theta can be expressed as cos of theta minus 90. So that's how, see in the first example, sine 120 will become the same as cos 30. No, because 120 minus 90 is 30. No? Understood? No? So just check out these three examples that I've shown you. Sine 120, sine 180, and sine 150. How they can be expressed in terms of cos also. The last one in blue pen, that is the cos one. Okay, so people, I hope all the questions on the board so far are clear to all of you. Now,
Yes,
moving on.
Yes,
just
sir.
1 minute.
Yeah, Ajay, you're writing now.
Yes, sir, please.
Yeah. Okay, so this is done now.
Yes, sir.
Okay, so let's move on to the fifth and final question. So the integration of this will actually become x to the power 4. So this will become 1 to the power 4 minus of minus 1 to the power 4 because it's an even power. So we'll see it becomes 1 minus 1 or 0. Okay. Integration of 4x cube. Take the 4 outside. That's how we get. And then you put the limits on this.
Done, sir.
Okay, very good. Okay, now we'll understand the next thing about definite integration.
So can you just scroll up for 1 minute?
Okay.
Yes, sir. Thank you.
So let's understand this concept of area under a curve from definite integration. So if we have a function whose graph is represented by this curve, so suppose this particular curve, it represents a function y equal to fx, and let's say this point on the x-axis is a and this point on the x-axis is b. Then if we just draw two vertical lines at x equal to a and x equal to b and calculate what is the area enclosed by the curve between a and b, this area is nothing but what we get from the definite integration. So this integration a to b fx is actually that area that I've labeled over there. So this is the area bounded by the curve y is equal to fx on the x-axis between the lines x equal to a and x equal to b. So this is the geometrical meaning of definite integration.
So this you have to any random curve, like.
Yes, any random curve. Okay. Okay, so for example, if I'm talking about the curve y equal to x square, parabola, let's say this point is 1. So this area we have how much now this area by equation.
Sir, your voice is breaking.
It will be 1/3 square units. Whatever is the unit that is x and y axis, whatever unit was used, it becomes square of that. Yes, beta, what happened?
Your voice is breaking.
Yes, sir.
Okay, so just make a note of this, then we'll discuss more about it. Yes.
Sir, excuse me, sir.
Yes, beta. This question.
Sir, your voice is terribly breaking. How could I say?
Yes,
Okay, I just got disconnected.
Sir, again,
Remember, just little while back, we were discussing about integrals like this.
so your
Cos
voice
x
is breaking.
from 0 to
Yes, sir, your
pi by
voice
your
is
2
voice
is
is
1.
breaking.
Then we saw sin x also 1. Okay.
Sir, we can't hear you.
Nor your screen is visible. Yes, sir.
Okay, people. So now you should be able to hear me properly again.
Yes.
Yes, sir.
Now it is proper.
Okay. So let's continue. So yeah, as I was telling you, we were discussing these integrals a little while back, and we saw that integration of cos x from 0 to pi by 2, it gave us the value 1. Similarly, integration of sin x from 0 to pi by 2 also gave us 1. Whereas integration of cos x from 0 to pi gave us 0. So let's understand geometrically what is the logic behind all this. Okay. So if we compare the graphs of sin x and cos x, we'll be able to understand at least why the first two have come out to be the same value, which is 1. So if we plot the graph y is equal to sin x, sorry, this is cos x graph. I'll just make a correction. But this is how the graph of cos x looks like. And if we compare that to the graph of sin x,
Sir, how can you say that the graph will be like this only?
this also I've taught you better. The graph of cos x and sin x, I've taught you in calculus in differentiation part before. Okay, and I told you that it's something important that you should understand this graph and remember it. Okay. So if you just revise my previous lectures where I had explained trigonometry in 4 quadrants and all that, the formula of ASTC and all that also. So you will recall all this from there. So the first one that we have calculated, this one, this is actually this area. This area is equal to 1. The second one that we have calculated, this one, this is actually this area now. Sin x from 0 to pi by 2, this area is equal to this. Whereas the third one you will see, the third one is this area plus this area. Okay, the sum of the areas from, and that's why it's coming out to be 0, because one area is on the positive side. So this area from 0 to pi by 2 is plus 1. But this area from pi by 2 to pi, you can see it's the same shape. It's like a mirror image of that, but it's below the x-axis. So the area is counted as minus 1. So that sum comes out to be 0. And that is the third part. That is why the area in the third part is 0. Similarly, if you take the example of this one that we have done, that integration of 0 to 2, 1 minus x dx, this had come out to be 0. Now, if you look at the graph of this also, it's rather simple because y equal to 1 minus x is a straight line. So we can even calculate the area in question by using formula of area under triangle or area of a triangle. So we plot this graph, y is equal to 1 minus x. We can see it will be a straight line of this type. Straight line of this type. This is a straight line with slope m equal to minus 1 and y-intercept c equal to 1. So that's why it's passing through this point. That's why this point will be 1 because the slope is minus 1 like this. Okay. Now we can see that the area that we're talking about between 0 and 2. So if you check out the value of y at x equal to 2, you'll see it's minus 1. So now this is basically the sum of these two areas, this area plus this area. So this area is plus of half base into height. That's 1/2. But this area, it is minus of, because it's below the x-axis. So it's minus half. So that is why what will happen is, if you were to integrate this from just 0 to 1, you will see your answer will come out to be half. If you were to integrate it from just 1 to 2, you will see your answer will come out to be minus half. But when you integrate it from 0 to 2, it is the sum of that positive area and that negative area, and that comes out to be 0, because they exactly cancel each other. So this is another way of verifying that it gives you the area correctly, because we have calculated the area using area of triangle formula as well as by using integration, and we're getting the same result from both of them. So it kind of verifies also that integration by definite integration, or by putting the limits, the quantity that we calculate, the value of the definite integration is nothing but the area subtended by the curve of the function y equal to fx between the limits x equal to a to x equal to b.
Sir,
Yes.
sir, how in first graph your area comes to be 1 because cos 90 is 0.
We just did that integration little while back, cos x dx from 0 to pi by 2. You can refer to it. It was that question, the a part was that only. So that's how it came out to be 1.
So you're showing the graphical method of it.
No, I have sent you what that represents now. What does the definite integration represent? It represents the area under the graph. It's not a separate method of calculating the integration. The method of the integration we have discussed earlier. What is the meaning of it? It gives you the area. So which area we're talking about, that is shown in the graph today.
Sir, sir,
Yes, beta, what's the question?
sir, in the third graph, how do you know it's a straight line?
Because see the equation, no? It matches that type y equal to mx plus c. y equal to 1 minus x में, what is the maximum power of x? It's a linear equation. The graph of a linear function is a straight line always.
Sir,
Yes.
sir.
so can you just
So,
scroll
sir,
up for that hyperbolic example?
Okay, come again. I didn't understand.
So can you just scroll up for that second example of this definite integration? And
Yeah.
ah,
This
yes,
one.
sir. Ah, yes, sir. Yes.
Yeah, Sakshi, you had a question.
yes, sir. So in the third graph, in that red thing you have written that only, that m is equals to -1
Yes.
and c is equals to
See,
1.
third graph. Yeah, we were plotting this line. Y equal to 1 minus x. So compare this with the general equation of straight line. What is the general equation of line? It is y is equal to mx plus c, where m is the slope and c is the y-intercept. So when you compare this, you can see what is x's coefficient m, it is -1. And what is the independent constant term, it is +1. So the slope is -1 and the y-intercept. Okay, so that's why that line was looking like this.
Yes, sir. Done. Thank you.
Okay, Sakshi, this is clear now?
Yes, so y-intercept means like where it will touch the y-axis.
Where it cuts the y-axis. Okay, so if you put x equal to 0, the value of y, that is nothing but the y-intercept. So in the equation y equal to mx plus c, if you put x equal to 0, what the value of y comes out to be? It comes out to be c. No? So that is the point where it is cutting the y-axis, because the x coordinate at that point is 0 and the y coordinate is c. Okay.
Okay, sir.
And I want to answer your question. No, from 1 to 3 it will not be 0. No, why it will be 0? 1 to 3, so it will be a negative quantity. So the same straight line, if we go to do something like this now, let's do this integration from 1 to 3. So I will now calculate this by two methods, because this is a straight line. So I can also calculate the area directly, or I can do it by integration. So by integration, I can see that I have to just apply that same method. First, calculate the indefinite integration. Okay. And on that, I have to put the limits. So the upper limit is now becoming how much? 3 minus 9 by 2. I won't write the c because anyway it will cancel out. And the lower limit is 1 minus 1 by 2. So it is minus of 3 by 2, correct? Minus of half. So it's coming out to be how much? Minus 2. Okay, now let's verify this geometrically. Okay. Geometrically, we can see that now why we can solve this question geometrically is because we are dealing with a linear function. So we can always calculate the area by using the formula for area of a triangle. Anything else and we could not do that. There's only one method to calculate the area, which is integration for any other type of function. But for linear function, luckily for us, whatever area it will be some kind of combination of triangles or just a single triangle. So this is how the line looks in general. In fact, we can extend it both ways. The line exists even for x being negative. You can
So
see that.
because the answer is it is in negative, hence you have made the slope downwards, no?
No बेटा, आंसर से कोई मतलब नहीं है. स्लोप डाउनवर्ड्स क्यों है? बिकॉज इक्वेशन ऑफ लाइन क्या है? इट इज 1 minus x. स्टैंडर्ड इक्वेशन ऑफ लाइन क्या होता है? mx plus c. So m का वैल्यू कितना है? -1. That is why it's like this.
Okay.
Same thing had it been y equal to x plus 1, then that graph would have looked like this.
Upwards.
It's been positive, yes.
Thank you.
Plus 1. Okay, so that is the point 1, and now at the point 3, let's say over here, what is the value of the y coordinate at x equal to 3? So you can see for x equal to 3, y is equal to 1 minus 3. That's minus 2. So this point is minus 2. So now what is this area? It's basically this area. No? So this area we can calculate geometrically only. This area is negative because it's below the x-axis, but negative of how much? half of base. Now the base is how much? 1 to 3, so just 2 units. And the height is how much? 2. You can see it's becoming minus 2. So geometrically what we are getting, see, it verifies what we are getting by.
Sir, can you re-explain in area mein what you did just now?
Half of base into height, beta. Area of triangle. This is a right angle triangle.
Okay.
The inverted one.
Okay.
This triangle is like this. So this base is equal to 2 units from here to here. Because this point is x equal to 1 and this point is x equal to 3. Okay, and this height, that is also 2. Because this point is y
sir.
equal to minus 2. This point is. Okay, so people hope this question is fully clear.
Sir, I'm drawing the graph thing. Just wait a minute.
So, so on this graph thing, the question will come for that.
See, the thing is, you have to understand one thing, beta. In your physics, whether it is the JEE exam or the NEET exam, there is no question that is going to come directly from calculus in physics, because this is not your maths paper. If you have maths as a subject, then yes, you can get a calculation based question directly involving definite integration or directly involving differentiation, but that will be in your maths paper, not in your physics. In physics, it will be application. So what we will see is these concepts that we're learning in calculus here, they are going to be applied in chapters like kinematics, later work by energy and all that. So the questions will be involving those kind of things. We'll calculate work done by a force using a method of integration. So you'll have to integrate that force. It won't be a direct question that some function is given to you and you have to integrate it.
Okay, sir.
Whereas if you have
Yes,
maths, then in your class 12 advanced calculus course in maths, you will see that you can get this type of question. Like some graph is shown and the function is given for the graph and you ask to calculate the area. So you have to calculate the area using integration.
Sir, but till now we have not done any application-based question. We have always
We have done
given a numerical type of
on
thing.
differentiation, we have done application based questions. Okay. Maximum minimum was application only. Like that in integration also we'll do application based questions.
Okay, sir.
Then when we start kinematics, that is the first chapter of physics where we'll see application of calculus.
Sir, can you again revise that maximum and minimum?
Okay, when the time comes for application, we'll do the revision. Okay.
Okay,
Now
sir.
let us look at some. Okay. Let's look at some examples of integration by substitution. What we had learned in the last lecture. We had seen there were two types of substitutions. Okay. The first type was linear. So that is when we have integration of some term like this. So here what we do is we substitute ax plus b as a dummy variable. Okay, so dx becomes dz by a. So the integral becomes so it becomes so this was one type. Okay, and the second type of substitution we had seen is when there's a composite function. So there we have something like this f of gx into the derivative of gx. Okay. So here what we do is we substitute gx as z as the dummy variable. Okay, so dx became g prime, or rather dz became so the integral became again f of z dz. So it became I of gx plus. So let's look at some examples of these things. So now we'll learn to put limits also in this.
Sir,
Okay, so let's calculate these. Yes.
sir, in the first one, linear substitution, after that dummy which you have substituted, why have you put a dz divided by a?
Okay. That has come, I had explained last time, because we put z equal to ax plus b. So if you differentiate this, what is dz by dx? It is differentiation of this term. So that will be a. So then you cross multiply. Remember, beta? This step you remember, na? So if dz by dx is a, then what is dx? It is dz by a. Just cross multiply. The same thing is done here also. This thing you differentiate. Na? If z is gx, then what is dz by dx? It is differentiation of gx. Na? So that is g prime x, the derivative. Okay. So that's how on cross multiplying this also we get dz over here is g prime x into dx. So this thing is substituted. This whole term is substituted as that. So that's how we get this.
You differentiated that term, it means.
Yes, beta.
Okay.
Sir,
Yes.
how we will come to know that a function is a linear or a composite?
You should be able to recognize in the function because linear function always has maximum power of x is 1. Whereas a composite function is a function of a function f of gx, right?
Sir, your voice is very feeble.
Okay, so people, let's check out the answer for the first three. So you can see that the quantity the function is operated on is a linear term. 2x is a linear term. So you substitute 2x as z.
You are not audible.
Yeah, I'm audible.
Sir, you are
The audio
audible.
is clear from my side. Okay. You can check your own internet connection once or your audio settings. So dz by dx is equal to 2. So dx becomes dz by 2. Okay, so this integral now becomes sine z dz by 2. Now the integration of sine z is cos with a minus sign. So this becomes minus cos z by 2 plus c. And finally resubstituting what is the value of z, it is 2x. So it is minus cos 2x divided by 2 plus c. Okay. Now,
Integration, na?
हाँ बेटा,
Towards
तो
the end.
इंटीग्रेशन ऑफ sin x क्या होता है? माइनस cos x होता है ना? Now, for example, Ayan, you have sent me an answer which is something like this, minus cos square x. Now you can check yourself why this answer is wrong. Okay, because if the integral is this, then what should be the differentiation of this? Now you differentiate this and see, you will not get.
Sir,
Yeah.
sir, how 2 can? It is a differential. It's a differential of 2x now. अरे मैं फोन बंद थी क्यों? अरे यार.
Okay. No, actually, minus cos square x will also be correct in its own right, because so it's another way of expressing the same answer, but it's a little bit indirect. So why the integral is minus cos square x, you can also justify in this way, that you can see that cos 2x can be written as 2 cos square x minus 1. This is an identity in trigonometry. Therefore, this term minus cos 2x by 2 plus c can be written as minus cos square x plus c, because c is the indefinite constant term. So this minus half will get absorbed in that. This will become minus 2 cos square x plus 1 whole divided by 2 plus c. So that is minus cos square x by 2 plus half plus c. Now this plus half plus c can be written as one constant. Okay. Sorry, that by 2 will not be there. So this can be absorbed in the constant and written as c. So that's why this is also equivalent to minus cos square x by 2. Sorry, minus cos square x plus c. So this is also all right for the answer. Yes, what is the question, Piyu?
Sir, I want to ask, can you explain this in an easier manner?
See, this is the easiest way, beta. See, what is the function? The function is sine function, and what the function is operating on? It's operating on 2x. No? So what is 2x? Is it not a linear term? It's linear. No? So whenever we have a linear term inside the function, what do we substitute? You substitute the linear term as z. What is easier than that? इससे आसान तो कुछ हो ही नहीं सकता.
Sir, I understood till that. After that arrow में you wrote on the left side में. That I part and not.
Which part, beta?
Sir,
The
left
integration is
side.
clear up to this part. It's clear up to.
Yes, yes, sir. Yes, sir.
Okay, so this is trigonometry now. This is an identity from trigonometry. That cos 2x. You know the formula of cos 2x in trigonometry? Okay, it's cos square x minus sine square x, and can also be written as 2 cos square x minus 1. So I'm making use of this identity. Okay, so this is a trigonometrical identity. So if you make use of that trigonometric identity, then you can reduce it to this also. Okay, if you don't know this trigonometric identity, there's no problem. You just you answer this way. This is correct.
See, till there also okay, na?
Yes, this is the correct answer. You can reduce it to this, but it's not necessary.
Okay, sir.
All you need to do is follow up to this step which I've tick marked over here. Is this clear?
हाँ sir, till then that it is clear. After that what we did थोड़ा सा difficult.
Okay, very good. Okay, now Sakshi, you have asked the same question which I was asked before, that how do we know it's a linear term or not? So a linear term is of this type. The maximum power of x is 1. Na? So it's very easy to recognize a linear term. So for example, if I have this thing, I can see that inside the square root, this is a linear term. Okay. But if I have this thing, I can see inside the square root is not linear. Na? It's a sine function. So the overall thing is which type of function? It's a composite function. This is of the type f of gx, where gx is sine x and f is the square root function. It's just a matter of observation. Hope the point is clear now. Okay, let's move on to the next question. So you want to do e raised power 2x plus 1 from 0 to 2. So again, you can see on the exponential, the power is which type of term? It's a linear term. Na? So the integration is done in the same manner, that for this, you substitute the linear term as z. So dx becomes dz by 2.
So how dz by 2 comes? So that is 2x plus 1.
बेटा बार बार एक ही चीज में क्यों समझाऊं यार? वहां पे सिखाया था ना कि z अगर ax plus b है तो dz by dx कितना है? इसका डिफरेंशिएशन है ना?
हाँ,
तो dx कितना हो गया? dz by a हुआ ना? तो वही चीज तो यहाँ पे रिपीट हो रहा है बार बार बेटा. पिछले क्वेश्चन में भी यही था, इसमें भी यही है. Okay, so this is the indefinite integration. So what we now do is for the definite integration, we put this limit. I mean, we put the limits on this indefinite integration. So this is the indefinite integration, this one. Now on the same one, if I put the limits 0 to 2, suppose. So on the antiderivative, which is this term, I put the same limits. So the upper limit will become e raised power 2 into 2, 4 plus 1, 5 by 2. Okay, and the lower limit will become e raised power 0 plus 1, so that's e divided by 2. So it's e raised power 5 minus e whole divided by 2. Or we can even write it like this, e into e to the power 4 minus 1, like this also. Okay. So we can leave the answer this way, where you know that e's approximate value is 2.7. Okay, so make a note of this also. All right, so this was the second one. Let's move on. The third one is 1 upon 2x plus 3, integration of that from 0 to 1. So again, you can see the denominator is a linear term. So substitute that linear term. So dx in the numerator will become dz by 2, sorry, because the coefficient of x is 2 again. Okay. So the integral, this will become 1 by 2 dz by z. And bring the half outside. So this antiderivative is the ln function. So the integration is 1 upon 2 ln of 2x plus 3 plus c. So this is this indefinite integration. So now when we put the limits on this, we just need to substitute the limits on the right hand side on the antiderivative function. So upper limit will become 1 by 2 ln of 5, right? And the lower limit will become 1 by 2 ln of 3. So you can take 1 by 2 common. You can use the property of ln, that ln a minus ln b is ln a by b, and that becomes your answer. Just like we also have the property that ln a plus ln b is ln of the product of a and b. And one more property that we have is ln of a to the power n is n times ln.
Sir, on the second step, half. So you did integration. No. So you
That
did
integration means integration. Integration of dz by z is ln z. That is the exception case to the x to the power n rule. Remember, when n is equal to -1, we get that ln integration.
Sir, so here n is equals to -1. kahan hai?
That is z denominator में है ना बेटा. So what is the power of z? -1 ना. 1 by z क्या होता है? Z to the power -1 होता है ना.
Yes.
So in second last day, what you did, I didn't understand.
I have written it above. Is the property of log, which I have taught you earlier also. That ln a minus ln b or ln 5 minus ln 3 is ln of 5 by 3.
Okay.
Okay, let's come to the next one. Okay, so now we have those composite function type of integrals. So we'll discuss. So here you can see it's not a linear term anymore. For example, in the first one, you can see that the denominator is 1 plus x squared. So it's not a linear function. So obviously it's a composite one. Okay. But luckily for us, what we have that in this one, you can observe that this function, if you take it as gx, then what is the derivative of this function g prime x? It is 2x now, and that is then the numerator. Okay. So therefore, what we should do, we should substitute z as gx, or in this case, substitute z as 1 plus x squared. So therefore, dz by dx is 2x, or on cross multiplying 2x dx is becoming dz. So this thing along with this thing can be substituted. So the integration of 2x upon 1 plus x squared, the numerator 2x dx can be substituted as dz, and the denominator 1 plus x squared is z. So this is ln z plus c, and z is nothing but 1 plus x squared. So This becomes my answer. So this integration is 2x upon 1 plus x square. This integral is ln of 1 plus x square. So this is the antiderivative. Now all you have to do is put the same limits on the antiderivative and get the answer from that. Okay, so same approach we'll see for the next question also. You can see that inside the square root there is a sine term, so it is a composite function. But also sine's derivative is cos, and cos is there outside. So we can always substitute sine x as z, or as the dummy variable. Okay. So complete the fourth problem after putting the limits, okay, and calculating, and then come to the fifth question. Try out what I just told you.
So,
Okay, so let's just discuss the answer for the fourth part first. So that's very easy, or to just put the limits on this integration now. So integration of 2x dx upon 1 plus x square, but with the limits 0 to 1, now becomes ln 1 plus x square as the antiderivative. So on that, put the limit 0 to 1. So the upper limit is ln 2, put the value of x as 1, and the lower limit is ln 1, and that will just give you finally ln 2. Okay. So it will be ln 2 divided by 1, so that's ln 2. So that's your answer. The final question.
Sir, it will
Cos x
become ln1, no? 2 minus 1.
ln 2, ln of a minus ln b is ln of a by b, no? So what is ln of 2 minus ln of 1? What is 2 by 1? It's 2 only, no?
Yes, sir.
2 by 1 2 होता है ना कि 1 होता है? Is it clear, beta?
Ah, yes, sir.
Okay. So now in this again you see that the term sin x, if you substitute sin x as z, then dz by dx is cos x. So that means cos x into dx can be substituted as dz. So this whole term and just rearrange it a little bit and write it like this. So you can just rearrange it a little bit like this and write it like this: the root of sin x into cos x dx. So this whole term cos x dx, this becomes dz. Okay. And the sin x term becomes z. So the integral becomes root z dz. Now this is easy to integrate. This is z to the power half. So z to the power 3 by 2 divided by 3 by 2 plus c. So it's 2 by 3 z. Now z is what? Sin x. So 2 by 3 sin x to the power 3 by 2 plus c. So that is this indefinite integration. That is the integration of cos x into root sin x dx. Now again, you have to just put the limits on this. So if this integration is this, then 0 to pi by 2 of that same integration is 2 by 3 sin x whole to the power 3 by 2. On that you put the limits. Okay, this. So the upper limit becomes how much? 2 by 3 sin pi by 2, which is 1 to the power 3 by 2, minus the lower limit becomes 2 by 3 sin 0, and sin 0 is 0. So this just becomes 2 by 3 minus 0. So answer becomes 2 by 3. So that's the final answer. Okay, people, so hope this question is clear to all of you.
Yes, sir.
So with this, we finally conclude calculus, right? We're done with this. And next lecture, we'll be starting with the next chapter, which will be kinematics. Okay. Kinematics will have a little bit of application of calculus, but not very difficult things like simple differentiations and simple integrations. So just do a revision of all the concepts that we discussed, and from there onwards we'll take it further.
So
that's it for
kinematics of the board lecture which we have to revise.
No, I said board lecture, forget about it. That's not important for these lectures. Okay. Board lecture is for when your college exams and all that happen, you can revise that. Kinematics I'll be doing from the basics again, so you need not revise the board lecture. I'm saying do a revision of the concepts you learned in calculus for future.
Okay, fine.
Okay, so that's it for today, people. Wish you all the best. Have a nice day.
Thank you, sir. Have a
Thank
good
you,
evening.
sir.
Thank you, sir.